Find the area of the triangle ABC. Here the coordinate of A is given, that is 1, 3, 2. Coordinate of B is 2, minus 1, 1, and coordinate of C is minus 1, 2, 3. And you have to find out the area of the triangle. Suppose this is the triangle having three vertices A, B, and C. The coordinate of A is 1, 3, 2. Coordinate of B is 3, 2, minus 1, 1, and coordinate of C is minus 1, 2, 3. And we know area of a triangle is equal to half into magnitude of the cross product of two sides. Suppose if you take a suppose you take a parallelogram, draw a parallelogram like this, you see, then the area of this parallelogram will be equal to cross product of two sides, adjacent sides, that means this side and this side, and this is the diagonal. Okay, so when you find out the area of the triangle, you will take the cross product of the adjacent side, this side and this side, not this side. If you take this side, then the area you will not find the area. And to find the area of the triangle, you have to take half of the area of the parallelogram. This is the parallelogram, and half of this parallelogram is equal to the triangle. So area of the triangle will be equal to half of BC cross CA. This side BC cross CA. So you have to find out the side BC, the vector BC. BC will be equal to, as you know, if you have two coordinates, suppose x1, y1, z1 and x2, y2, z2, then the distance between the two coordinate will be equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. That formula you apply here. So BC vector will be equal to, you see, minus 1 minus 2 I cap, minus 1 minus 2 I cap, then 2 plus 1 j cap, so 2 plus 1 j cap plus 3 minus 1, 3 minus 1 k cap, minus 1 minus 2, that is equal to minus 3 into I cap plus 2 plus 1, that is 3, so 3 j cap, 3 minus 1, that is equal to 2 into k cap. Similarly, you can find out the vector CA using the same formula, x2 minus x1 into I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. You find out the vector CA, that is 1 minus 1, sorry, 1 minus minus 1, so 1 plus 1 I cap plus 3 minus 2, so 3 minus 2 into j cap plus 2 minus 3, here the coordinate is 2 and here the coordinate is 3, so 2 minus 3 into k cap. So this will be equal to 1 plus 1, 2, so 2 I cap plus 3 minus 2, that is equal to 1, so 1 into j cap minus 2 minus 3, that is equal to minus 1, so minus k cap. So after finding the two vectors, that is BC vector and CA vector, you find out the cross product. As we know, to find the cross product, you have to take the determinant. So here I have written the determinant of the two vectors. For BC it is I cap, j cap, k cap. This is your k cap, j cap and I cap, and the value is minus 3, 3, 2. So minus 3, 3, 2, and for this vector CA, 2, 1, minus 1. So 2, 1, minus 1. If you find out the determinant, then the value will be equal to I cap 3 into minus 1. So 3 into minus 1, minus 3 into 2 into 1, so minus 2, minus j cap into minus 3 into minus 1, that is equal to 3, minus 2 into 2, so minus 4, plus k cap into minus 3 into 1, that is minus 3, minus 3 into 2, that is equal to 6, so minus 3, minus 6. So the result will be equal to minus 3 minus 2, that is equal to minus 5 into I cap, plus 3 into minus 3 minus 4, that is equal to minus 1, minus again minus plus, so plus j cap, minus 3 minus 6, that is equal to minus 9, so minus 9 k cap. And we know area is equal to the magnitude of this vector, cross product of this vector. So magnitude of BC cross CA. BC cross CA is equal to 5 pi minus 5 pi cap plus j cap minus 9 k cap. So magnitude of this vector will be equal to square root of minus 5 square plus 1 square plus minus 9 square, and minus 5 square is equal to 25 plus 1 plus 9 square is equal to 81. 81 plus 1 plus 25, 107. So square root of 107. So area of the given triangle will be equal to half of square root of 107. So in this way you can find out the area of a triangle if three coordinates are given.